very important product that Gen 3 make is one that measures electrochemical migration on circuit boards or inside circuit boards. We have a machine here which is called SIR, AutoSIR, and that is used to measure the resistance on the surface. So again, we're looking for residues that might have been left on the board from a process, or we're doing a fundamental characterization of a flux or a coating using this machine. It can measure many patterns simultaneously, up to 256. We have very good sensitivity. We measure down to very low currents or high resistances. Again, we're looking for a pass-fail type response. The standards talk about a resistance that has to be greater than 100 mega ohms, which this instrument can easily measure well above that. So we can characterize things, material sets, and this is now very important in terms of objective evidence that IPC talk about in their new J standard 001, because if you want to have some evidence of a material set, which could be the circuit board, the plating, the solder paste, the components, the cleaning, the coating, and so all these come together. While you may have some evidence for these individually, you now have to evaluate it synergistically with everything in the complete round, and you can make this circuit board or use them to make a circuit board which you can test, and you can use this machine to monitor or tell you how well you've done that job. If that proves to be good and you're happy with that value, then you can take that process and say you could use that to make another board, which you can use with the contaminometer, and then that forms your golden board, your reference level for that assembly, using the process which you've just proven with the SIR. So SIR is really important in establishing that baseline value for your process. So this is the electronics that drives it. Over here we have a rack which has many slots into which we can plug test cards or calibration cards, and we do this test in a damp heat chamber, an accelerating condition. So this is a damp heat chamber, and inside we see another rack which has some test boards already in there. So we can run our test, which may last up to a week or 168 hours or even longer, 1,000 hours. And then the other one type of test that this instrument can also do is called a conductive anodic filamentation test, or a CAF test. And here we're now looking for residues that have been left inside the circuit board, and there are latent defects or pathways through which this CAF can flow, and we can pick up the presence of that CAF electrically with this type of instrument, but that would now be an AutoCAF. One of the robustness things that we see in the industry is conformal coatings. So conformal coatings are coated over the assembly, covering up the components and protecting them from condensation or even water. Coatings historically have not been very good at covering the edges of a component, the so-called sharp edge coverage problem. And the SIR test in a damp heat chamber on its own has not been very good at showing up this weakness. So we've been working on a new type of test, and we will be bringing that to the market later this year, where we control and generate a known condensed water film on the component, on the assembly. And now if we have a sharp edge exposed, then the migration path is now across the top of the coating to the other sharp edge exposed, so that comes like that. So we'll be launching a product called AutoCHT, condensation humidity tester, which allows us to form this controlled condensation environment and tell us or characterize the coating's ability to cover sharp edges.